Hey guys, what's up everyone? Welcome and welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akeen, your math instructor, and in today's video we're going to be looking at a applied question that's related to measurement, length of arc, area of segment, sector, and also applying a little bit of trigonometry to help us start this particular question. All right, so this was one of the questions that is related to a previous upload that I had made related to this particular paper. This is an exam paper for my students, and so I'm just pretty much doing a tutorial video to assist them with the application towards this problem. So let's see if we can work together and try to get some answers done here. So as you can see on screen, we have a circle, right, with a few points on its circumference: point A, point C, point B, point E, and point D. And it is here marked by center O and an unknown angle indicated by alpha. And we have a diameter and a few radii. All right, so here it says that the diagram below shows a circle with a segment ACB. So you can see that that segment is shaded. And there's a diameter AOE that's measuring 19.4. And of course we have the chord AB, this is down here, is 14.7. So we could perhaps put that in from now, 14.7. Okay. All right, and if we have that here, then we see here that and an angle alpha where AO and OB are two radii in the circle. We are instructed to use pi to be 3.142, and the questions that are here are what we are going to solve here. All right, so it's a healthy it's a healthy amount of marks: 3, 4, 7 to 9. 9 and 3 is 12. 12 marks for this. Let's see if we can get some work done here, guys. All right, so we're looking to find the angle mark alpha. All right, so we're looking for an angle. So more than likely there's two topics that should come to mind, which is the geometry statements for angles, or we are looking at using maybe a trig formula, maybe a sine ratio, tangent ratio, cos ratio, cosine or sine rule, maybe one of the above that was mentioned. So let's look at what we have. We only have one present side, which is 14.7. So I'm guessing that half base times height cannot be used because we don't know what the height is. So we can't use that. We cannot use AB, or let's say here, the only thing that I'm thinking about here is that we could probably use the cosine rule. And you must be wondering why the cosine rule, because one of the criteria, which was explained in a previous tutorial of mine, that one of the criteria for using cosine rule when finding an angle is that you must be provided with all three sides. So you're looking at the diagram here and you're probably wondering, where are the lengths of the other two sides? Where do we get those from? But it did say here that AOE is 19.4. So this distance here from here to here is 19.4. And since that is the diameter, then the relationship between the radius and the diameter is that the radius is going to be half the length of the diameter. And so these here are going to be radius 1 and radius 2. A radius is a line that is run from the center of the circle extended to the edge of the circumference, and that's what we describe as a radius. So therefore then we would know that 19.4 divided by 2 gives us a distance each here of 9.7 and 9.7. So that is how now we end up having all three sides. So therefore we could use the cosine rule to find the angle mark alpha. All right, and if you're wondering what the cosine rule is, then a previous tutorial was posted on my channel. A link will be provided in the description box below. Check it out if you guys want to know the rules for using the cosine rule. So that's c squared is equal to a squared plus b squared minus 2 times A times B, or 2AB, multiplied also by the cosine of the angle, which in this case we're using alpha. So let's go back to the diagram. We need to figure out what is it that we refer to as being A, B, or C. All right, and we cannot just choose a letter to represent any side. It has to be very specific. So we're going to be choosing C to be 14.7. And why? Because C, depending on the criteria that's presented, then C can either be the side that is unknown, or it's going to be the side facing the angle that is unknown. So in this case here, 14.7 is the side we're going to be using to represent C. And it's not because I have C here that I'm using C. I'm just using C because it's the side that is facing the unknown angle. All right, so therefore then we're looking here that C is 14.7, and that's going to be equal to 9.7 squared plus 9.7 squared, those are the other two sides, minus 2 times 9.7 times 9.7 times, obviously we're looking for the angle alpha. We're going to get to that in a moment. So we're going to have 14.7 here squared, and that's 216.09. And that's going to be equal to 9.7 squared. That's 94.09. And we squared again, so that's 94.09. And then immediately we're just going to multiply what we see here, 2 times 9.7 times 9.7. So that's 2 times 9.7 times 9.7. And that's 188.18, obviously multiplying by cosine alpha. Alright, we just need to simplify this equation here. So we have 216.09, and that's equal to, when we add these two, we end up getting 188.18. That's minus 188.18 here, cosine alpha. Now, a couple of mistakes that I saw whilst marking this particular question on my students' paper were that you guys constantly forget that you are not allowed to subtract here, because you would have been subtracting an trigonometrical variable here from a numerical value. So the 188.18 over here is married, as we say, to the cosine alpha. So subtraction is not possible here. What we're going to have to do is some transposition, because we need our subject here, which is cos alpha, attached to 188.18 to be positive. So at the moment here it's negative. So if I can do, say here, a little transposition and bring it over here, then I'll end up with 188.18 cosine alpha, and that's going to be equal to, say here, 188.18, which is this one. And we're going to bring this over here. That's going to be taking away 216.09. So if we proceed here and we say that 188.18 cosine alpha, and that's going to be equal to 216.09, we end up with negative 27.91. So if we proceed here, we'll find that cosine alpha is equal to, just dividing both sides by 188.18, we end up with negative 27.91 divided by 188.18. All right, running out of space here, guys. I'm going to head up here. So if we divide those two, okay, so we're going to have here that cosine alpha is then equal to 27 negative 0.91 divided by 188.18. The answer should be a negative result, so that's negative 0.148. So that's negative 0.148. All right, and so alpha is going to be cosine inverse, or arc cos, of negative 0.148. Do not forget to insert the negative into the calculator. We're expecting our answer to be greater than 90 degrees here, so cosine or arcsine cos inverse of minus here 0.148, we're getting an answer here of 98 degrees approximately. So alpha is approximately equal to 98.5, so that's 99 degrees. Okay, so the angle that is actually between here is 99 degrees. All right, so we can just erase this alpha here and put, whoops, let's see here, I don't think I have enough space, so I need to, it's not working, guys. I think my eraser is a little bit too big. So let's just turn it down a little bit. All right, here we go. So we can just write inside here our angle is 99 degrees. All right, so we're good with that. Let's move on now to finding the area of the shaded region. So this region down here, which is the shaded region, is known as our, say here, minor segment. So we're going to have to call upon the formula for this sector and also the formula for the triangle. All right, so notice here that this section of the diagram here has a triangle that is mounted on top of the segment, and the segment and the triangle is what makes up what is known as the sector. So if you're going to find this red portion here, we're going to need to take away the area of the triangle away from the area of the sector. So if we subtract the area of the triangle from the area of the sector, we're going to get the area of the segment. And so that is how we go about doing that particular problem. So let's write down our formula here. We're gonna have area, whoops, pardon me guys. So we're gonna have area of, say here, segment, okay, is gonna be equal to the area of sector minus the area of the triangle. Okay, so we need to call upon the sector formula. So that's going to be theta divided by 360 multiplied by sector is going to be a fraction of the area of the circle, so that's pi r squared, and the angle which we had calculated to be 99 divided by 360 should be multiplied by, they did see that we should use pi as 3.142, and the radius we had calculated earlier was 9.7, and we're going to be squaring that. Okay, so 99 divided by 360, that gives us 0.275. We're going to multiply this then by 3.142 multiplied by, say here, 9.7 squared. We end up with 94.09. So if you go ahead now, 0.275 multiplied by 3.142 multiplied by 94.09, we end up with, say here, 81.29, or let's just say round it off to 81.3. Alright, and that's going to be the area of the segment. I believe here that the unit of measurement that we were using for the segment was, say here, centimeter. Was it? It's centimeter. So that means our answer should be 81.3 squared centimeter. That is the area of the sector. Alright, so that we've completed this aspect of the problem. Now the area of the triangle. This we could use Heron's formula because we have all three sides, but that's a little bit lengthy, so we could actually use the sine formula, which is side by side times the sine of the angle between divided by 2. All right, we could use this formula. It's a lot easier, right, instead of the Heron's formula. So A is equal to AB here, which is 9.7 multiplied by 9.7 multiplied by the sine of 99 divided by 2. So 9.7 multiplied by 9.7 multiplied by the sine of 99, we will get 92.93. all right, and then we're going to divide that then by 2, so we should get a final area here of 46.47 rounded off approximately. Okay, all right, so now that we have the area of the sector and the area of the triangle, if we subtract, say here, 46.47 from 81.3, then our final answer for the area of the segment, which is the shaded section, is going to be equal to 34.83 squared centimeter. All right, and that is the area of that red shaded portion that we have on this particular diagram. All right, so here we go, guys. Let's have a look here. So this section down here measures, see here, 34 point, I believe we just calculated it. Okay, all right, pretty good. Let's move on to part C here. Find the length of ADB. So that's length from here, from A coming around to D, coming all the way around to B. So we're looking for that length. All right, so we're basically looking for the major arc, the length of the major arc. So we're going to be calling on to our arc length formula. All right, and that is a pretty similar setup to that of the area of the sector. It's just that here is theta divided by 360, but because we're looking at the distance around the circle, we're going to be multiplying it by 2 pi r. Okay, and so again the angle is 99 divided by 360. This time we're going to be multiplying it by 2 times 3.142 times r, which is 9.7. all right, so we did earlier had calculated 99 divided by 360, so we had already known that this is 0.275 multiplied now by, say here, 2 times 3.142 times 9.7. we get an answer over here of 60.95. all right, now we just made an error, all right, because I think what I'm actually calculating here is the length of the minor, because we're using the minor angle. Let's just go back to the diagram here. So this particular angle that I'm using here, 99, is the angle that the minor arc subtends. So we should be actually using the angle that's around here, okay, because that's the length of the major arc. All right, so I think the error that I made here would have actually been, say here, the angle should have been 99, or pardon me, 360 minus 99. all right, so that's 360 minus 99. So the angle that we should have been using for theta here is 261. all right, so if we go ahead now and say 261 divided by 360, we get 0.725. right, so this should have been 0.725. So if for whatever reason you may have calculated using the minor angle, and let's say we had gotten here 0.275, you could have taken 0.275 from 1 and you would have gotten the decimal value of the major angle. But nevertheless, quickly type that on your calculator. You should confirm that you're good to go. all right, so then we have 0.725 multiplied by 60.95. we end up here with a final distance of 44.19 rounded off. all right, and that's the length of the major arc. So the only error that I expect you guys to make would have been here, say, the incorrect angle which you would have used. all right, Next, then we're going to be looking at the area of the major sector. Area of the major sector. All right, so the major sector would have been obviously here, and that's the sector, so that's everything. Let's do the blue. So that would have been everything here. All right, that would have been everything around it. That's the major sector, pardon me. So we had initially written down a formula for sector. So the formula that would have written down for sector would have been up here, right here, because this was the sector formula. All right, and that was the area of the triangle. So the formula here is theta over 360 times pi r squared. So theta divided by 360 multiplied by pi r squared. Remember, it's the major sector that we're looking for. So we'll be looking for the angle that is, say here, 261 divided by 360 multiplied by 3.142 times the radius squared, which is 9.7 squared. Now what I like about this particular here, well, I don't have to use up a lot of my calculator, because I would have already known that 261 divided by 360 from previous calculation here would have worked out to be, say here, 0.725. But if you want to go ahead and do it one more time, no problem. So that's 0.725. And I would have already calculated earlier 3.142 multiplied by 9.7 squared. Most of the answers are already done. We would have calculated it here, but I think I had calculated everything at once, so I didn't multiply it here. I had just written down this, then I've written down that, then that. So I'm gonna have to do the calculation. All right, thought I had the answer written down, guys. So that's going to be say 3.142 multiplied by 9.7 squared. Sorry, 3.142 times 9.7 squared. So that we got 295.63, and if we multiply that then by 0.725, we would have gotten here that the area of the major sector is 214.33 or 0.3 squared centimeter. All right, so that pretty much ends that particular question. All right, healthy little question here, brought out a lot. We had to call for a bit of trigonometry, we had to call for our length formula, we had to call for our segment formula, we had to do some interpretation, crossover, overlapping, and such and so forth. All right, so nice question here. Hope that this tutorial was able to help you get a bit more clear understanding of a question like that. Look out for questions like those on your CSEC exams, and hopefully this tutorial was of assistance to you. All right, do take care until next time. I'll see you in another one.